Okay, we're going to run through this 66 Ampeg Gemini II now that it's all done except for the new trim bug, which I'm waiting to arrive in the mail. And I'll just go through everything we've done. Step one was the old filter cap had to go. Besides the fact that it was old and leaky, a previous tech had absolutely butchered it. It was using the wrong stages. He had 340s instead of 80-40-40. And instead of connecting to the ground to the cathode, the shared cathode of all the anodes, he had the grounds connected to the unused anode. So these three filter caps that he had in here, those sections, were not connected to anything. They were not functioning. There was no ground reference. Second, there was a dual 20 microfarad filter cap, which was mounted mounted here. There was a little clamp on the board with wires going everywhere. That was in the wrong place for the circuit in terms of noise, and I'm not going to mess with a dual section 22. So I've got some FNTs mounted here where they actually are connected in the circuit. There was room on the board. They're secure. That's good. All right, back down to this end. After getting the filtering set up, I want to remove the old 2-conductor non-grounded power cable, put in a new grounded power cable with this nice clamp, the old standby switch, which both standby and polarity. I removed the polarity function because you don't need that when you have a ground. And ground goes straight to chassis here. The reason this wire is longer is long like this rather than going straight here is if this cable were to get pulled out, I would want the ground to be the last thing to disconnect for safety. But anyway, all right, so the standby switch is now just doing standby, no polarity function. The standby is recommended on this amp. It doesn't have a tube rectifier. And when the B plus is loaded, it's right about 480. But an unloaded B plus on this amp before the tubes get warm would exceed 500 volts. And in time, that could hurt the brand new cap. So the hot of this wire goes to the fuse, then to the power switch, which is down here, and then to the primary on the power transformer. The neutral is going directly to the other primary on the power transformer. The bias is active whenever the amp is on. It is not affected by standby as it was in the original. It had really fugly diodes here. I've put in these two. I might actually go back now that I know what the final B plus of the amp is and do some in series. So instead of single 1 in 4007s, I'll have 2 per side. So instead of handling 1,000 volts on the peaks, it can handle 2,000 volts on the peaks. It's not that likely that you're going to get 1,000 volt spikes, but diodes are cheap enough. A little bit of peace of mind won't go amiss. All right, there was a big carbon comp 1-watt resistor here. This is essentially the screen resistor for both output tubes. This is the screen node, and it was out here, and it was on flying leads that was very fragile with a lot of stress on these joints. I replaced it with a 5-watt low mass 470R, so there's no stress on those leads. The new bias cap. This amp did not have adjustable bias as it came in. I put in an adjustable bias circuit. It had the center tap for the heater filament supply. Center tap was running to ground through a 100 nanofarad cap, which is a stupid way to do ground. So I've left that center tap here, not connected to anything, and I've installed an artificial center tap here on this output socket using 100 ohm half-watt resistors. It gives you a better balance, and if something were to go wrong in the heaters, one or both of these would burn as opposed to the center tap burning, the actual physical tap. So instead of the transformer burning, you lose 2 5-cent resistors, and it's very easy to replace in the future should be necessary. All right, going through, this amp had a lot of coupling caps that were too large in terms of the value compared to the schematic, and I did some math, and the schematic was correct. So where the schematic had 22 nanofarads, this particular amp actually had 100 nanofarads, and the whole thing was very woofy. So I've replaced all those hundreds and put in the proper 22s. Here in the cathodione phase inverter, I've decreased one cap quite a bit and added a little bit of grid resistance to lessen grid clamping. On the outputs, I went from 100 to 47 just to get a little bit tighter response. As you can hear in the video, the amp's got tons of lows. It just doesn't have the flub now. You can see here where this glue is. This is where the heater wires used to be, and those heaters were right in parallel and close to that grid there. And these grid wires were actually glued to the blue and the yellow heater wires. So they were right up against the heaters and in parallel, and there was a lot of buzz. So by moving these wires from where it was glued to here and moving these two grids away from this heater wire and this heater wire, both channels are just about dead quiet in terms of heater response. Both channels were a little bit anemic. I changed one cathode value on this stage and put a bypass on it. I changed two cathode values on this stage and put a bypass cap on the first. Gives a nice gain increase, and critically, with the first cathode in each stage fully bypassed, helps reduce heater hum. Let's see. I gave the reverb a similar boost, but the cathode, because it's a little bit weak. Just putting a cathode bypass cap there. All the other coupling caps have been replaced. I would use Mallory 150s for all these. This was originally a WEMA gold foil 470 nanofarad, which I don't think was original to the amp, and it was actually faulty, which is one of the reasons that the reverb was really weak. So brand new cap there, that's good. Let's see, that's the trim roach I'm still waiting on. This amp had a very strange circuit on both channels where if you turn the treble all the way clockwise, it would click and turn on a bright cap. So when the amp was already at its most trebly, you could then add a bright cap. That was just painful to be in the room with and useless. But without that bright cap, each channel was a little bit dark. So the stock bright caps that were connected to the switch, I've moved just to the volume pot at all the time. And it gives that nice air. It makes the treble and bass pots much more responsive. By some miracle, these little cards in the tone stacks of each channel, which have some capacitors and resistors built into them. That's an Ampeg thing. Both of them are still good. All the pots are still good. They just need a little bit of cleaning. This amp originally had input jacks labeled accordion and guitar on each channel. And the accordion was high gain or fullest gain, but relatively low input impedance, where the guitar was high, very high input impedance, but was 5.6 meg, but had a voltage divider ahead of that. So I've changed each of these to the Fender style, where you have the fullest gain, high impedance, lower gain with a lower input impedance. It works for Fender, it works for Marshall, it works for Vox, it works with this Ampeg too. Let's see, anything else that comes to mind? All the other resistors are pretty much good. These I replaced because I wanted to change the value, but these resistors were good, which is kind of rare in an amp from this era. But these carbon films that Ampeg was using are better resistors than the carbon composites that Fender was using. I was able to reuse the 33K that was in the bias circuit here as the part of the adjustment circuit. That's the same trim pot that we usually use in Marshall repairs. It's very sturdy. So the Gibbs reverb tank is working fine. I had to replace the switch for the echo reverb on-off on the foot switch. That's just a standard Carling, the same as was made and used in 1966. Oh yeah, the original 7591As were not great. Both of them were very, very weak. And one of them was much weaker than the other, and was getting a little bit, the one which was stronger was getting a little bit of a cherry after a while. So those are being returned to the amp, and a new matched pair of tongue saw 7591As are installed. And the amp is biased about 58 to 60% idle dissipation. One's at like 56, the other one's at 60, so split the difference. There's always going to be a little bit of mismatch. As well within spec, people go to great lengths to exactly match output tubes, and there's no real point to it. You get when there's a slight difference, you get more interesting sounding output. As long as the difference isn't so wide that one draws more current than the other, or you get hum because there's no common mode cancellation, you're fine. The preamp tubes are good. One of the RCAs was a little microphonic. I've moved it to the tremolo circuit where it's out of the audio path. So we've got a Mullard here, and an RCA here. The reverb driver tube is good. The 7191 phase inverter, which is a pentode front end followed by a triode, which actually drives the cathodione, is noisy. After you turn the amp on, it takes about 2 minutes for it to stop going. And if you brush it against it, it'll still make the occasional. There's an oscillation to it that comes and goes. Mostly it goes, but when it comes, it's very annoying. And if you tap on it, it sounds like Thor hitting something with his hammer. So this is going away, and I'm actually going to take the 7199 out because these things are getting ridiculously expensive. I'm going to move 3 wires here and put in a 6U8A tube, which is on order. I've been told that the difference is so minuscule as to not matter. I'll let my ears be the judge of that. After I hear the 6U8A in here, if I don't like the sound compared to what this is behind the noise, we'll find a 7199 and I'll put the wires back. But I'm pretty sure that the 6U8A will be just fine. There's not a lot of gain in the pentode wiring, and the amp's got tons of gain to spare, and the cathodione is almost a unity gain circuit, so it really matters if the tube is good and quiet more than anything else there. But we will find out. I think that's about it for this amp at this point. I wish I had the original speaker to check because I like having the whole amp, but this was shipped to me from North Carolina, so everything you can do to save on shipping costs makes sense. Okay, stay tuned for when this bug is replaced, and then we'll hear how it sounds with a fully functional trim.